Hi there, we're going to look at arithmetic sequences today. Now, I'll be honest, these are really just sequences that you saw at GCSE, and that's GCSE, they were given a different name. GCSE, very often they were called linear sequences. Linear because they go up at the same amount each time. But traditionally at A-level, they're called arithmetic. So arithmetic, or as you can see, it really just spells arithmetic, but everyone always pronounces it arithmetic. So arithmetic sequences are no different from what you saw before, and finding the nth term of these, really you could use the old methods, but I'm going to teach you a new method, and there are reasons for this, and that's because on harder questions it's quite handy to have this to fall back on. So bear with me for a bit, because the linear sequences that you've seen before will seem to you like, why are we doing this a new way? And yet we're doing it a new way because it's useful for tricky questions. So anyway, here's a little starter first. How many discs are there in the 10th tower? So I'm just trying to get my head around this. I've got 2, I've got 5. Oh, I see. They're going up 3 each time. That's, I suppose, what you're meant to be saying to yourself. Every time you do this, you get an extra 3 discs. So the 10th one. And I suppose the other thing I'd want to do, what's the nth term? Well, at A-level we tend to write this as UN. UN equals, it's going up in 3s, so I'm going to call this 3n. But 3n is 3, 6, 9, etc. And you can see I'm 1 too many, so it's 3n minus 1. And therefore in the 10th tower, U10 equals, well, 3 10s, take away 1 is 29. So I know how many is in the 10th tower, 29. The question might be a bit harder if I want to add up all these numbers going up to the 10th tower. Now, I should point out, actually, there's perhaps one way of doing this. What's the one before that? The one before that would be 26. And we've got all these numbers, and you can just see there's a little trick here if you spot it. 2 and 29 is 31. 5 and 26 is 31. And I reckon because there's 10 numbers in total, there's 5 pairs like that, all adding up to 31. So I reckon really they add up to 31 times 5, which is 155. Now this is a little trick that you can sometimes do with well, you can always do it what we now are calling arithmetic sequences. You can add the first and the last terms together and times by the number of pairs of those. Let's just check my answers, 29 and 155. So my trick did work. An arithmetic sequence then is one that goes up the same amount each time, 10, 13, 16, 19. We call the amount it goes up by each time. In this case, you can clearly see it goes up by 3. We call this the common difference. The common difference is something that you'll be expecting. An exam question might say, find the common difference. So you definitely want to make note of the fact that this is called the common difference. And if we get away from the words and we just want to write a bit of algebra down, perhaps, we just write d equals 3. So on that basis, here's a second example. What's going on here? Well, now it's going down by 3 each time. So again, it won't surprise you to learn we write this as d equals minus 3 because the common difference is minus 3. And I suppose the way you find it, you always you get one term and you take away the term before it. So if you like 21, take away 24. Gets me my minus 3, and that's the way you always do it. You don't have to be. I could have picked 15 and taken away the one before it, and you're always going to get the same answer. That's why it's called common. It's a common difference. So our arithmetic sequence, when this goes up the same amount each time, we've said that this first term is 2, the second term isn't 2, it's 2 plus the 3, which is 5. The third term is 2 plus 2 lots of 3, because you can see I've added on 3 and then I've added another 3, and that gives me my 8. And the fourth term, well, I've added another 3 on, so I've written 2 plus 3 times 3. And so I suppose the nth term is simply something connected with that. It's the first term. Notice this symbol here, a, that's the first term, plus n minus 1 times d. This is the formula that you're meant to learn, and notice it says it's not in the formula book, but we are going to be expected to know this. A then is the first term, D is the common difference. Arithmetic sequences, it says, can also be called arithmetic progressions, or simply just written as an AP. I've seen questions that say an AP has these terms, and you're meant to know that it's an arithmetic progression and therefore an arithmetic sequence. We'll use that formula loads. It says find the nth term there. Notice I've written it here, by the way, as well. This is my formula. Find the nth term in the following sequence. Well, just notice straight away a is 6. My first term is 6. I need to know, I suppose, and this is what find the nth term. So I suppose I can just write this straight away now. How much does it go up by the way? Oh, it goes up in 4s. Goes up in 4s. Goes up in 4s. So definitely here D equals 4. So I need to know this, I said. So it's A is 6. I'm just going to write this formula out again. That's the formula I want you to learn. UN equals 6 plus n minus 1 times by 4. Now, it's probably best if we multiply this out. Two things to multiply out there. You get 6 plus 4n, take away 4. And that is 4n plus 2. Now look, this is why I said you're going to have to bear with me a bit. Because in all honesty, you probably saw this straight away and said it goes up in 4s and we need to add on 2. You probably knew it was 4n plus 2 about a week ago. But this formula approach helps us in other situations. So do please bear with me. It also says how many terms are there in the sequence. So we saw how to do this before in another example. If you ever ask how many terms there are, you set your nth term equal to the last term. So I'm going to go 4n plus 2 is equal to this 122 here. And that will tell me which term it is that we stop on. So move the 2 over. 4n equals 120. N equals 30. There are 30 terms in this sequence. That's what that tells me. So what are my answers? 4n plus 2 and 30. Find the 20th term of this series. So again, what I want to do really, I suppose, I want to get the UN term. So over here, I'm going to write A equals, well, it's 2. That was easy enough. And I want the D. What's the D? Well, it goes up in 3s, goes up in 3s. D equals 3. So my UN, which of course it says is A plus n minus 1. D, I want you to write it so you get a chance to remember it. The nth term will be UN equals 2 plus n minus 1 times by that D, which is 3. And again, I'm going to tidy this up. 2 plus 3n minus 3. And UN equals 3n, I think, minus 1. And again, I know you could have done that much quicker using GCSE methods, but this, I promise you, will prove useful. Now, I haven't actually finished the question yet. It says find the 20th term. So U20 is 3 times that 20, take away 1. And that sounds like 59 to me. So that's part A done properly. Well, I say part A, it wasn't even labelled. The first part. Will 512 be in the sequence? So they're really saying, will I eventually get to 512 if I go far enough? It's a long way away at the moment. But look, the way to do this is to take our equation that we had, our UN equation, the term we just found, and you set it equal to the number they want you to do. Because look, we're quite happy with the first term, the second term, the third term, the fourth term, etc. But you'd be surprised if they said, look, the 4.3th term. I mean, it doesn't work like that. So the terms have got to be integer values, whole numbers, first term, second term, third term, etc. So on that basis, if we set 3n minus 1, what was it equal to? 512, equal to 512. If I get a decimal answer, I'll know it's not a sequence, in the sequence. If I get a whole number, an integer, it will be. So first job, move the 1 over, I get 513. And so I've got to do 513 divided by 3. I'm like, oh right, it is. I didn't expect that. And I half expected that to be a no. But it's 100, n is 171. So yes, this is in the sequence. That's what we now know. Okay. And yes, it is in the sequence. So good. So next question, example. The 5th term of an arithmetic sequence is 7, and the 8th term is 16. Now this is the kind of example I think it's useful to start thinking in terms of this formula. So let's go with this. Now the fifth term is U5. And just using my formula over here, a plus n minus 1d, well, what is n? Well, in this case, n is 5. So a plus n minus 1d is a plus 4d. Notice I'm adapting my formula for my question, the fifth term. And that says that it's equal to 7. And when it's the eighth term, n is 8. So U8 is a plus n minus 1. That's 7. D equals 16. So this allows me effectively to work out the values of a and d. So I type these into my calculator, simultaneous equations. So menu, go down to the A, simultaneous equations, 2 unknowns. So what have I got? I've got A, which is 1, 4D and 7, 1A again, 7 and 16. And this should tell me value of A. So I get A is minus 5. And what's my D? I get 3. And that's enough. So again, we put this into my equation. My equation, of course, is this A equals A plus n minus 1D. So I want the 100th term. So U100 is minus 5. Nearly missed my minus. Plus, again, n minus 1. I want 100. So 99 times by the D, which is 3. So that's 297. I reckon 292. Fingers crossed. 292. First three terms of an arithmetic sequence are 12x. Now look, all of a sudden you're starting to see why I'm insisting that you should try to do these using a A-level method rather than a GCSE method, because they're starting to get a bit weird. My first three terms are 12x squared and 5x. I don't know what the other three other terms after that. It says find the possible values of x. Well, the one thing you know is if you have, say, 3 is your first term, and then, I don't know, 11, and then, well, that goes up 8, so presumably 19. Now, you can work out the common difference by just doing a subtraction. You can go 19 take away 11 is 8. Or you could do 11 take away 3. You can do anything you like, as long as you take one number away from the one before it. So it will always give you the same answer. So that means, I reckon, x squared take away 12 has got to equal 5x take away that x squared. You've got to get it the right way round. But effectively, it gives us, because it's an arithmetic sequence, it gives us an equation which we can then solve. So let's move everything over to the left for a second. It gives me 2x squared, and that becomes a plus, minus the 5x, minus the 12 equals 0. So this is a quadratic equation. So again, I'm going to cheat. I'm going to go menu A. It's a polynomial of degree 2. And what we've got are 2x squared, negative 5, and negative 12. Well, it says my answers are x equals 4 and x equals minus 3 over 2. And I suppose if I wanted to try and make it look as if I've done this properly, I'd write x minus 4, change the sign, and 2x plus 3, change the sign and bring the 2 up. And that does give me 2x squared, so that works. They're my answers, they're my possible values for a minus 3 over 2. I've even written it the same way round. Look, that's it, we're done. Exercise 4C then is what we're going to practice in class. I think it's quite a nice little exercise.